Cambridge, historic town of dreaming spires, academic excellence, punting on the River Cam, and jungle music.
Always carry a sound system because you never know when you're going to need to DJ. So I live in Cambridge and I'm a scientist, but for the last few years I've been running a company that I started called Novalia, and it's all about adding interactivity to print.
Novalia might look like an average print company, but there is one big difference. Their prints make a lot of noise.
So this drum poster's fun, you can touch it, it plays some beats, but we also make print that is Bluetooth and can connect through to your smartphone and then can connect onto the internet.
Using a thin layer of ink containing nanoparticles, Kate has printed electrical circuits on the paper.
This one is like a soundboard.
After giving a TED talk on nanocarbon inks, Kate demonstrated some scratch DJing on paper. Then she was contacted by a very special fan.
A year later, I got a message from probably the best scratch DJ in the world, DJ Qbert, to say, hey, seen your talk at TED. I'm bringing out my first album in 15 years, and I'd love you to make the album cover. And we want working DJ decks in the album cover. And we've partnered with the DJ app company, and it's probably been the hardest thing we've ever done.
Kate's nanocarbon inks have converted Qbert's Humble Album's sleeve into an interactive electronic conductor. Via Bluetooth, the mixer on the sleeve controls the DJ app on the phone.
When someone touches them, it's almost like they lose where they are and they get a massive smile on their face, just like they're a child. And actually, they're learning about technology without even knowing they're learning about technology. And I get massively inspired and rewarded by seeing that.
But nanocarbon inks have become more amazing since the discovery of the world's latest wonder material, graphene. Graphene is just one single carbon atom deep. Stronger than steel and transparent, a piece the size of a football pitch would weigh less than a gram.
Well, graphene is special because it has a lot of superlative properties which are much better than any other material, like strength and conductivity and flexibility and transparency and all that. But the most important thing is that it's all of these things in one material rather than a different material for each.
Graphene was first isolated at Manchester University. It may be the most advanced material in the world, but it's produced from graphite, or as most people know it, pencil lead. When graphite was first dug out of this mine near Borrowdale in the 16th century, they didn't know what to do with it, so they used it to mark sheep. Now, Manchester University researchers Nick and Sarah use graphite to produce graphene.
The normal sort of graphite that you dig out of a mine would look something like this. It's kind of rocky looking. But if you get really lucky and find a nice pure piece, it will have this shine to it. Now, this is nearly all carbon arranged in these two-dimensional layers held together by weak forces, which means that when you write it on paper, you can actually shear off some of the carbon layers.
We can describe the structure of graphite like a pile of paper, where it's easy to slide the sheets over each other, but they tend to clump together. But if I use a piece of sticky tape, then I'm able to pick up just one sheet.
And we can play the same trick with graphite. If I take a flake here and stick it down onto sellotape, I can then peel the rest of the flake away, leaving a thin layer of graphite behind. So this will still be quite a thick piece of graphite, but obviously if I peel it, it will become twice as thin. Split it again to make it 4 times as thin, and then 8 times as thin, and I can keep going.
And that's the key. If we do this enough times, we get down to a single layer of graphite, and that's graphene.
At Manchester, Nick and Sarah are part of a multidisciplinary team that are working hard to get graphene out into the marketplace.
We have people from physics, chemistry, material science, engineering, maths, biology. So basically pretty much every discipline, even the business school is involved in doing studies on graphene at the moment.
For all its amazing qualities, graphene isn't substantial enough to be used on its own. The Manchester team are working out ways to layer graphene into other materials to change their properties.
In terms of these layered materials, I think it's a very unique situation where you're actually making structures which nature doesn't make.
If the team can scale up the process of graphene layering, the possibilities are endless. Flexible screens, improved solar cells, DNA sequencing, and even faster electronics.
Keep a smile on your face.
The strength, conductivity, and transparency of graphene offer new possibilities to Kate. With pure pieces of graphene suspended in water, graphene ink is tough enough and transparent enough to be printed directly onto any surface with a normal printer.
The F major scale.
There's a piece of transparent plastic laid over the graphics, and on that transparent plastic we've printed some graphene ink, and we're using graphene as a transparent conductor. So when I touch this button, it connects to my phone and makes the music play. So we've created a fun experience, but actually its purpose is to inspire. And we have no idea where this is going to go or where graphene is necessarily going to end up. More likely than not, it's going to be combined with other inventions, other pieces of technology. And it's when we combine those things together that we end up with properties, experiences, or technology that we've never dreamed could happen.